All right, I think we'll get started. Thanks everyone for joining us today. I really appreciate you spending time with our technical team today. I'm Michael Downs, I'm the CTO for Evolving Solutions. And this webinar and a couple of others we're going to do over the next couple of weeks started as the idea from some of our account executives who wanted to give our clients the opportunity to see some of the content that our technical team shares internally and from time to time with our clients as well. So with a broader audience and working from a distance, we thought it would be a good opportunity to share some of these things. So I'm sure most of you know who Evolving Solutions is, but I wanted to take a chance to introduce this a little bit for anyone who might be one of our clients that is joining us for the first time. We provide solutions to a variety of different businesses in the Minneapolis area, as well as surrounding states, and nationally as well, and internationally for some of our clients too. But we provide technology solutions to modernize and automate your business critical infrastructure. And I think one of the things that really differentiates the way that we work and the way that our clients, the things that our clients are looking for us to help them with, is what we call our modern operator approach. So we'll dive into this a bit deeper during the presentation today, but I wanted to share this with you. Really, we look at cloud and we look at the way that operations is transforming as less about a place per se and as about a way of doing business. And modern operations for us is really about how do we take advantage of the kind of work that you've always done, that you've spent the last probably 20 to 30 years, depending on how old your business is, optimizing your company to do, and be able to take advantage of those same operational practices in a new world while learning from the new practices from a cloud native environment, so we can really optimize the way that our clients go to help their clients, help their businesses be successful. So today we're really going to talk about, we wanted to have a conversation about containers and Kubernetes. And the reason that this was a topic that was so impactful, we thought it was a good place to start was many of our clients have asked us about this, everything from are people really doing this to how do I make this work into production to what's the impact to my operational day-to-day operations as I start adopting this kind of technology. So I've asked a couple of enterprise architects from our team to spend some time going through this. They're going to share a bit of a presentation that they've done for a couple of clients, but also for our internal team as well, that really, we thought, laid a good foundation for containers. And I know from the number of clients on the call, there's a variety of different sort of maturity levels with the container environment on the phone, on the WebEx today. And we're going to start from sort of the beginning a bit to make sure that we've all got a shared place to have a conversation. So I'm going to pass the presentation over to one of our presenters, over to Phil Fisichella. Phil is an enterprise architect, as I mentioned. He has an extensive background in a variety of enterprise architect and architecture roles. I like to say that he was doing containers before containers were cool, back in the Sun Microsystems days in the late 90s and the early 2000s. And Art Mills is also joining us today. He also has an extensive and broad background in solution architecture and enterprise architecture, and has done quite a bit of work helping clients understand how to adopt container technology. So with that, I'm going to hand it over to Mr. Phil Fisichella, and we'll go from there. Thanks for joining us today.
I think you'll end up handing
Michael,
it to me.
we're actually going to hand off to Art Mills first. If you handed it to me, let me go send it over to Art.
Yep.
My fault.
That's okay. Art, you are now the presenter.
Thank you so much. I will present my screen. And I will present the slideshow. And so, as Michael said, this is a very introductory review of containers as a general rule. Containers with orchestration, which is a critical thing that a lot of people think they can start with containers, maybe stop there. And then a very brief demo. This is not, if you're very familiar with Kubernetes, if you're very familiar, if you're already well along your journey in the Kubernetes space, this may be a little too, 101 for you, but this is a really good kind of introduction just to understand why this new way of working is important, how it will benefit you, and what it'll look like kind of as you're going forward. And so to start that, what we like to talk about is kind of the history of containers and orchestration. Containers are not a new topic. As Michael points out about Phil, Phil was working with with the containers way back in the day with Sun. These are concepts that originated in the 70s to isolate application code on Unix, which is what they're doing today, just on Linux. Docker went open source in 2003, and that kind of enabled containers to go mainstream. You could play with it, you could understand it, you could kind of dig into it and kind of understand a second level of virtualization, because by then everyone was already virtualized generically on VMs as a primary way to deliver their infrastructure. The modern containers leverage Linux, and they use things like namespaces and profiles and CG groups, etc. They're based on kind of how Linux is built, and then they present those things through the Kubernetes abstraction. Early on, orchestration platforms emerged. Google's Borg, Apache's Mesos, Facebook's Tupperware. These platforms were very, very good at kind of dealing with and moving the underlying infrastructure around to kind of satisfy the containers on top of it. The underlying infrastructure was the exact same. It was homogeneous. Would I pronounce that correctly, somebody? But it was built that way, so that way those basic platforms could control everything going on in an automated fashion. But it wasn't enough. As Kubernetes kind of became more and more of a thing, just dealing on the VM level with some container level wasn't enough. And so the kind of orchestration management wars kind of kicked off. Docker Swarm in 2014, built on Docker itself. Kubernetes obviously also in 2014, and Mesosphere kind of built on the ability to kind of control the Mesos, kind of ecosystem. These allows you to get very detailed control of your infrastructure as code through software, through automation at birth, not let me build it a couple times and then make it automated. It's automated directly right away. This orchestration was designed to tackle kind of a unified management plane, portability, being able to move your workloads anywhere, anytime, anywhere that Kubernetes in this case can run. You can run these workloads the exact same way, simply by directing the workload to the appropriate cluster, wherever it is, no matter what hardware it is, no matter what cloud it's in. Over time, Kubernetes did emerge as the clear leader and kind of unified option for people to utilize. Why is this? There's some differentiating views as to why. A lot of people say it's as easy as AWS, which was and it still is the most popular cloud, introducing the Elastic Kubernetes service on November 29th, 2017. That put Kubernetes mainstream. Everybody who was using AWS for any purpose at all had the ability to access these fantastic new containers. After that day, the main competitors to Kubernetes began to fall in line. Pivotal as changing their ecosystem to run on top of K8s. Mesosphere doing the same. Docker the same. Recently, obviously, VMware with their major Tanzu announcement has announced that they're going K8s native, and they're going to go to a lot of their Heptio purchase back in the day, bare metal with containers kind of at birth as well. Google has a different view as to why Kubernetes won, and I can kind of align with it. Google's view is that Google has been running containers or server workloads. So in the Google world, in a Google data center, a server isn't an object, a machine, virtual or physical. A server is software that can run on any machine. So a server in old school Google is just a container today. And they've been running that at scale long before the world knew anything about Borg or K8s or containers generally. Unlike Kubernetes, or unlike competitors, Kubernetes is designed, it can run anywhere on any infrastructure using one kind of unified abstraction layer. So a pod is now your server. A service is what you use to connect to the pod. A volume is how you kind of map out your storage to whatever backend storage you're using. Namespaces separate your tenancy. So it gives you the ability to control either in one large cluster with multiple groups or applications or environments like dev, stage, prod. These are now unified. No matter where you're running, it'll look the exact same from a code standpoint. And it's declarative application programming, simple files, simple YAML files to kind of run everything. Things that even if you're not technically advanced, you could probably read a YAML file and kind of understand what's happening, why it's happening, and where things are going. Ansible is a product by Red Hat that is actually kind of winning the kind of automation war, because they also use the same kind of thing. At the same time, Kubernetes kind of took off in its adoption. Ansible has kind of enjoyed the same level, because it's just as easy. It's just simple to understand for anybody, even if you don't have to know a specific code. You simply write a YAML file. YAML is the new HTML, I guess, right? And it's got a rabid, amazing, smart community. If you don't have that, you can't be successful, because you need to have somewhere to go to get help. You need to have people who know the product well enough to help you advance what you're doing within your company. A place to go for that, by the way, if you're looking, is the Cloud Native Compute Foundation. It's cncf.io. Great levels of information, kind of understanding how the pieces all fit together. We'll go into that in other talks, but that's kind of where we are right now. And I think at this point, I am done with my initial presentation. I will pass it over to Phil, and then if anybody has any questions, please feel free to use the, sorry about that, Phil, I gotta go over to you.
Q&A session.
Q&A
Art
session,
will monitor the Q&A session as I'm doing my presentation, and he will pass over to me, and we can answer your questions as needed. Let me just
should be there.
share. Be there in just a second.
Hopefully you guys are able to use the Q&A, because, but if you have any questions, just feel free to ask them, and I will stop Phil or do whatever I need to do. So.
Well, thank you very much, Art, and welcome everyone. Excited to be able to talk to everyone and also answer questions as necessary. So we want to talk about what a basic container infrastructure is here. I'm going to ask for some patience here, because there's a specific methodology I'm going to follow. This is very 101. And as you can see with the graphics, I'm a technologist, not a graphic designer, so I appreciate it. So we're going to talk about building what a container looks like on a virtual machine already. This could be the same for a hardware-based as well. Within that virtual machine, we're going to have an operating system, Linux, Windows, whatever. We'll get into that a little bit more. On top of that operating system, we're going to have a container runtime interface in this case. And as Art explained, Docker is kind of the de facto. On top of Docker, we're going to build our containers. Those containers share the operating system of the virtual machine. However, they have their own libraries and dependencies per container. On top of the container, or within the container, the actual application or application stack, substack will reside. I want to do a little bit more information here on the containers. They're very isolated environments. They have their own processes and services, as we discussed already. They have their own network interfaces. That's very important to keep in mind as well as you're managing your network TCP/IP layer. They do share the same operating system and kernel. That is what that container is physically on. And it's very application subcomponent focused. Typically, you don't take an entire application stack and put it within one container. The goal here is to separate out each piece of that stack into its own container. Want to kind of step back here for, again, from a 101 perspective, we want to talk about containers versus virtual machines and do a comparison. Here we have our typical container infrastructure on the left that we just discussed. On the right, we're going to talk about now virtual machines. Virtual machine still has its own hardware infrastructure and an operating system that is sitting on the physical node. On top of that operating system is going to be a hypervisor, VMware, whatever may have you. Within that hypervisor are actually going to sit your virtual machines. The virtual machine is going to have its own operating system and its libraries and dependencies that are for that entire operating system. And then you have the full application stack that sits within that virtual machine, typically, be it a database, web, whatever, the application stack is sitting within that virtual machine. So that's a quick comparison between containers and virtual machines. Now let's talk about running containers on virtual machines. We're going to start with our typical hardware infrastructure, operating system, and hypervisor for the VM. On top of the hypervisor, we actually have our virtual machines. We have the operating system, libraries, and dependencies for that virtual machine. And then on top of that, we have the container runtime interface, Docker in this case, on each VM. And then as we saw in the previous slide, we can set up our containers within the virtual machine running the container runtime interface. That's how it typically looks. For the most part, we're seeing a broad acceptance with just running containers on virtual machines, and you can still run containers in a dedicated physical server as well. I want to talk about Windows containers just a bit. We had a client recently that we addressed this with, and I thought this was good to include in the presentation. Within the environment, we're just going to address this from the VM level. We're going to have 2 Linux machines and 2 Windows machines, and there's a specific reason for that. It could be multiples of each, but we still need this to support Windows containers. One of the Linux nodes must be a master node for Docker. We can set up a secondary node as a worker on Linux. Here's where it gets a little tricky. Windows can only be a worker node. It cannot be a master. So this is a typical setup for Windows. It needs to be the same version of Docker that sits on the Docker master on Linux. It's important to note that only Linux applications or sub-applications will run in containers on those Linux machines. If you want to do Windows, those Windows applications can only run on that Windows virtual machine. Again, very operating system specific. That's why in order to support Windows containers, this would be a basic setup. Now we want to also talk about orchestration. I'm going to try to click through these a little bit slower than normal just so you get the impact. When we have a when we have no orchestration and we're installing an application across multiple nodes, it's a very manual process in order to set up each container manually. If for some reason we need to increase the size of a container, we are now creating new containers with that new sizing, and we're turning off the old ones. At this point in time, developers have been developing a new application, let's say version 2 of this particular application. Actually, I'm going to back up a little bit. I want to show one more thing. As we need to extend for the containers in this environment, it's a very manual process to install each container manually. At this point in time, now our developers are ready with version 2 of this application, and they come to the infrastructure team saying, okay, we're ready to deploy. An infrastructure member would need to then take that new application, manually install each container and each component separately into the production environment. If we need to increase the number of containers after it's been deployed, again, it is a very manual process to show or to do the increase of all these containers. So let's talk about, we do need to remove those old containers that we had destroyed from before. Again, a very manual process. If we need to now take this version 1 of the application and remove it, again, it's a very manual process. You're removing each individual container that was supporting version 1 of the application now that version 2 is in full swing. And after so much time, there it
Sorry,
goes.
Phil. That's one
Yes.
thing. Just one thing to add to that is that in the manual world where you're doing it yourself, if you leave behind, you forget there's a container there, or somebody had added a container and you didn't know it was there. If one of the old containers is sitting there that's running the old application and it's still behind the same load balancer or global traffic manager as the new application, you will actually route traffic to it. So you'll have customers going to the wrong application. It creates quite an issue of overhead and management to assure that your new version has completely taken over for the old version, and that there's no way your old version can actually take traffic still. And this is a very common mistake in environments that don't have orchestration kind of as part of it.
Thank you, Art. Great point. So a couple things to note that when you adopt orchestration, there is increased to speed to market, also number of IT projects that can be handled because the orchestration is going to automate everything that I just showed you from a manual perspective. I'm not going to read each one of these bullets except for the very last one on the right where it says it enables infrastructure as code. That is very important, and Art will kind of give you a little bit more information about that towards the end. But it's truly getting off of infrastructure, and your developers now own your stack. not from a hardware perspective, but from the container perspective. Let's look at what this actually looks like. Same application, same environment, but now we're actually introducing orchestration or Kubernetes. Version 1 of the application is ready for it sets up applications as necessary. If for some reason the one of those containers need to grow, let's say it's a database, the orchestration can handle that based on parameters that you already have built within Kubernetes. If you need to extend the number of containers from a workload perspective, again, Kubernetes based on the configuration will just automatically extend those as necessary. Version 2 of the application has now come out. So you work through the orchestration to deploy that. It will just deploy those containers as necessary. As you need to increase the number of containers for workload, it'll extend again as necessary. And once you're done with the application itself from a version 1 perspective and you're ready, Kubernetes again just takes care of that for you. Again, all this is pre-built, or I'm sorry, not pre-built, but the settings are already set by you, the infrastructure team, in order to get this to work properly. And you also set up your parameters, etc. I also want to take a look here at another example from a Kubernetes perspective. In this application, we are going to have 24 containers that are spread out across 4 nodes evenly. That makes up this one particular application. Orchestration will also handle if there is a failure of one of the containers, it runs into an issue, it's automatically going to stop that, and it's going to spin up a new container, again, based on the 24 container parameter across 4 nodes. If an entire node were to become unavailable for whatever reason, again, Kubernetes will automatically deploy those running containers, new versions, or I'm sorry, new containers onto the other 3 nodes to maintain that minimum of 24 24 containers for this particular application spread across evenly. Unless there's any questions, I'm going to hand this back over to Art so that we can do the demo.
And to Phil's point there as well, the important thing is that this is where your architecture comes in now. You're no longer architecting necessarily by application, you're architecting by cluster. You are now architecting, here's the size and scope that I want, and here's how much redundancy I need to allow 1 node or 2 nodes or 10 nodes to fail and still cover my environment. I need them to be placed in regions or availability zones, depending on which cloud provider you're in or which company you're running in. Those things are critical because Kubernetes will do what it's supposed to do so long as you have architected the cluster correctly to allow it to do that. And we've only had one question so far from Tim. I've answered the question privately about the link. Again, if anybody has any questions, please do feel free to jump in and put anything there, and Phil will be watching that. I am going to start with my little demo here. The demo can be a little bit longer than we're going to have it here. We're in the interest of time, I'm going to focus mostly on some of the differences in this new world from what you may be used to. This is not a secret. If you go to LinkedIn, you can see where I've worked. I have been I've been at Medtronic, I've been at Carlson, I've been at Target, I've been at Allianz Life. And when you're doing in an old enterprise waterfall methodology kind of company, a deploy of an application. Very typically, a developer has written some level of code. They have some environments they're running this in. Those environments probably don't look a whole lot like prod, or they maybe did look like prod at one point, but then because they were given rights and they added things and they didn't tell anybody, it may no longer look like prod. And then when it's time to do the actual deploy, because we in the enterprise as operators correctly fear devs destroying our universe, we don't give them access to prod. So what we then do is we take this code that we've never seen, that we don't know runs, that we don't know the differences in the environments they've been working in, and we install it for them. I remember at Medtronic, every 6 months, we would have 400 people get on board, and we have a big party, and it'd be themed, and we'd bring in food, and we were there for 24 hours, and we would do these great deploys, and when we were done, we would cheer. And that is not the way to do it anymore. And so when Phil says kind of infrastructure as code, and you're giving a lot of control to your developers, you are, and you're not. Kubernetes allows you to have the most control you'll ever have of your environment while seemingly giving complete control to developers, in that you control the security posture of your systems. You control exactly what's on your systems. Nothing can get there without your blessing. There is no direct login. There is no ability to give a direct login to an end user to put something on. If you put something on, these systems can be removed and put back in. The systems are no longer matter. They're immutable. They're immutable systems that do a specific function, which is to host the custom application. So what would that look like? Here is what is a deployment. That is a very small deployment, but it's an interesting deployment in that this deployment is going to have a couple of containers. One container is going to serve the front end of my application, and one container is going to serve the back end of my application. And so when you're writing a YAML file for Kubernetes, you'll find that there's a lot of similarities. There will always be an API version. It's very common as this, but there's many API versions that you'll be binding to depending on what you're using. It's got a kind. The kind is what I'm doing with this file. This is a deployment kind. I have a pod kind. I have a persistent volume claim kind. I have a horizontal pod autoscaler kind. I have a lot of different kinds that will kind of tell Kubernetes what type of object it's supposed to be creating on your behalf. I have metadata. Metadata is what you would expect it to be. This is the name of this deployment. This deployment will have one replica, which is one copy, which is great for development, but maybe you want 10. So you just put 10 there if you want it in prod, right? You're going to have labels. You're going to have names. You're going to have ways to identify, who's the owner of this, what environment's it in. This is a very simple app, but this is just a container that lives in your repository. This happens to be going out to Docker to grab a Redis image from Docker, and the Redis image is going to hold in memory the information I want from this application. Obviously, you put your database there. You could put whatever you want there, but it's going to go out there and do it, and it's going to assign how much memory that the container can use. It's going to assign how much CPU that the CPU can use. It's going to set limits. If it can't go above this, it can't eat into the rest. It will limit it there. It'll also define what ports must be open to allow communication from wherever to this specific container. In this case, Redis runs on 6389. This deployment goes on to continue to tell you that, I have another container. This container is a custom container. This is something that, my application, my devs have written, and they have containerized. They put it into Docker, they've uploaded it to a repository. I, as the operator, have no idea what that is. And honestly, I don't care. The reason why I don't care is because they're running this container in whatever environment I've given them to run it in. It could be, by the way, be the same cluster in the development namespace, but they're running this container already. It is guaranteed to be the exact same anywhere else I go. Even if the underlying hardware is different, the container is immutable. It is built based on that registered object. So if they make a change and it doesn't work, you simply roll back to the previous one. If they make a change, it goes to this one, and every one container built after that will be the exact same. And it does the same thing. It does everything you want it to do. It does your memory, your CPU. There are no requests. There's no DNS requirements. There's no load balancer requirements because you're going to put that all in here. I want to build a load balancer in front of this. I want that to work. This is what your code is going to look like. And if I come into a running cluster, let me get name. When you run a Kubernetes cluster and you build it in the modern way using kubeadm, what it does now is it runs all of everything required for Kubernetes as a pod. These are all pods. A pod is not necessarily a container, but it's analogous to a container. A pod can run one or more containers. It is the smallest object that Kubernetes deals with. And what you're doing here is you're seeing that a generic Kubernetes deployment is going to have a number of pods handling a number of different things. Your routing, it's going to have your DNS, it's going to have your proxy, which allows it to understand where the actual item is within the cluster. This is obviously, a lot of this is specific to Azure because we're running this in Azure right now. Whatever your CNI, which is your network that you're running, it could be anything you want. NSXT, it can be Calico, it can really be anything you want as your underlying kind of software defined service, right? this all is what you're doing to run a basic cluster. In an application that this file I showed you here earlier, I have running right here. And so if I vote, obviously for a dog or a cat, and obviously it's probably wrong to vote for a cat when dog is an option. But this is all being sent from a front end, one application container to a back end application container. And in your new world order, that's just going to look like this. Oops, I typed it wrong. Right? And so that single infrastructure as code file I sent you or showed you earlier has done a great deal of work. It has stood up 4 pods, 1 on the back end, 3 on the front end, right? So you have 1 on the back end, 3 on the front end based on what you're putting in here, okay? It's got services. So the back end can't be communicated with on the outside, but it does have an internal cluster IP so that the cluster knows where to proxy this to. But the front end has a load balancer. And so this load balancer is what you put in your DNS, your public DNS or your global traffic manager, which send traffic to that front end, which is this. Right? It's created replica sets for you to understand what is being told to do. And obviously I have also added something called a horizontal pod autoscaler, which sets criteria for you to scale automatically. So I want 10 replicas if things are busy. I want 3 if things are not busy, based on certain level of CPU utilization. So I have 50%. If it hits 50% of utilization on my CPU, add a pod. If it falls below that, subtract a pod. This is a very simple scaling way, but you can do this. And again, it's just code, and it's tied to the name of the application, so you can do searches and you can understand kind of everything from that standpoint. And while I won't go into a huge, monstrous demo, if I wanted to simply do a deploy, I no longer need 400 people. I no longer need to have parties. I no longer need to have catered services, although all of those things are good and you can still give them to me because I like all those things. But if I simply type in a simple command which says apply that file, so that file happens to be on this system, I've already imported it from my GitHub, into the namespace demo. Once I hit enter, I'm actually going to get a working application. It's going to do all of those things you saw above. It's going to do them very, very quickly. If I paste this command in, I'm going to watch to see when this service comes up. So this is the front end load balancer, right? I see it's still pending, which means it's not yet ready. I can't access it from the internet yet. But now I can. So it is done. It's created a load balancer inside Azure because that's what I've told it to do. It can create a link to your F5. It can do whatever you give it control in your environment. But if I take this information here and I copy it and I put it into a new area, I have a new application. This is, again, it's going to look the same, but you see I voted over here. This is a brand new application I just created. It's just been made. And in this case, because it's just being made from that file I showed you, if I do search for my demo, it's a little different. I only have 1 pod in the front and I have 1 pod in the back because that's what I told it to do initially, right? But I still have my same deployments. I still have my same load balancers. I still have my same services. I still have my same replica sets telling it what to do. And this is what your new world will look like. It'll be simple YAML files that will seamlessly interact with pretty much any underlying infrastructure, whether it's in the cloud or on-prem. And it will give you the exact same look and feel across any environment, allowing you to provide the set of services that kind of define what a public cloud is. And that's key because a cloud isn't a place. A cloud is an operational model. It's a set of principles. It's delivering kind of the feel of self-service, yet with high security. And it's giving you the multi-tenancy, and it's pooling your resources, and it's measuring your utilization. These things become very, very simple when your orchestration layer is as complete and complex as Kubernetes has evolved into. And that's pretty much all I wanted to show you on this demo, because I wanted to give a couple minutes for conversation and everything else. I can go and show more if people have specific questions, but I'm going to stop sharing my screen. And we'll go back here. So we still only have one question in the Q&A. So does anybody else have anything else they would like to ask so we could, before we move on to the rest?
Did you see that question there, Art, from Chris?
Tim? I didn't see, I only see one from Tim. I don't see one from Chris.
Popped in, a listener asked how production ready, quote unquote, is containers on Windows? Looking for your perspective on that.
Yeah, so containers on Windows have worked for many, many years. Docker container running on a Windows server has worked for many, many years. Now, you won't get the full greatness of what Kubernetes can do if you're running Windows Server 2012, if you're running Windows Server 2016. If you're running 1803 or 2019, I guess, which is essentially just Microsoft's version of Linux under the name Windows, you get all of the things that are available here. And what Phil said is right in that if you're running a split cluster where you have several Linux containers and you have several Windows containers, in theory, everything that can run on the Linux container can also run on the Windows container, on the Windows node. But the things that Microsoft still has some proprietary things over, like IIS, in theory, Active Directory, although you probably wouldn't do that. Older versions of SQL, those would be containerized inside of just the Windows nodes inside your cluster. So is it production ready? 100%. Is it production ready the way you may already be doing production? Probably not. What I mean by that is if you're heavily involved in the Windows world, you're very, very heavily engaged and involved with Active Directory. You're using that level of authentication. And in the cloud native world, that's kind of a bad thing. You don't want to be tied to an external system like that. You want to pass tokens around. You want to do OAuth. Kubernetes, though, has realized that it can't go into many places that are complete Active Directory devotees with security groups that love centralized groupings and everything else, and simply say, change all that, which is what their argument had been from about 2014 till about yesterday. They've kind of realized they have to integrate with Windows groups. They have to integrate with Windows services. They have to allow Windows AD run as's. That's not quite there. That won't be production ready until sometime later this year. There is some beta stuff out there to allow you to do some run as now, but that won't be totally production ready until probably Q3, where it'll allow you to kind of fully integrate with an Active Directory for workloads that require that. But again, that will be more legacy kind of workloads that wouldn't be necessarily modern cloud native workloads, but they can both run interchangeably. It doesn't matter. Just those things will be more production ready as we go forward.
So that actually brings up a question for me. I know earlier this week we had some folks attending the Red Hat Virtual Summit, and one of the things that they announced and have been working on for a while was being able to run VMs on top of, or essentially manage VMs with Kubernetes, which is a little bit analogous to what you were just describing with the changes to Windows. Where do you see that happening? Do you see Kubernetes kind of taking over as an orchestration layer, even for VMs in some cases, or?
Sure, it's a good question. So this is Red Hat's kind of KubeVirt. If you go up to kubevirt.io, you'll see it. They also have a GitHub that kind of explains what they're doing. It's open source, right, as everything with Red Hat is. So what KubeVirt does is it kind of uses Kubernetes custom API to basically present kubectl, the ability to kind of spin up VMs, to scale out VMs, to scale them down. Now, obviously, you won't be able to do a lot of the things you can do within Kubernetes as far as some internal scaling on those, because they're designed to be VMs that are available for something else. But what it does, it basically gives you a very common way, if you get to the Kubernetes world, of running commands that are the exact same for whatever your environment is. Whether you're running an older legacy application that needs a VM, you're still going to run a kubectl. You're still going to create by file. And because you're just going to use a different API and you're going to create that file to generate a VM that is the exact same VM, no matter what, it can never be different because it's going to be pulling from the same source. So it's always the same as long as you're pulling from the same source. So that's a very interesting way to do it. They're kind of approaching the management of containers a little differently than maybe VMware is. VMware is really, they've ceded the war. They've kind of admitted that VMs are going to die off. Red Hat is kind of expressing that they don't think it's ever going to fully die off. It'll be interesting to see which way it goes. VMware will eventually try to make all of their stuff containerized on a bare metal node. Red Hat is giving you both that option and the option in a heavily virtualized environment to really commoditize the VMs you're presenting in a interface you're comfortable with, because if you're doing Kubernetes, you'll be very comfortable with kubectl commands.
Awesome, thanks. Appreciate that. Any other? I don't see any other questions in the windows. I don't. Did you guys have anything else you wanted to share, or Art, Phil, you're muted out there.
I mean, this is normally where
I'm back. So Art, yes, we do have a few more slides to share. If you wanted to share those, since you're already the presenter, you can go through those.
Yep, I will. So there are a couple more slides here. Let me present from. Shoot, let me go into here first. I got to share my screen.
So just for the customers and clients on the phone, this is a great example of actually getting the content that we do internally. We end up starting the slides, getting into deep discussions, and going off one direction or another, and then realizing there's more slides you got to share. So
always more slides. So
that's the meaning of a great conversation right there.
Right. So as Michael led this whole thing off with, and as I mentioned a couple of times, the benefits of your container organization, and presumably you're going to be picking Kubernetes if you do that, is that it gives you the ability to deliver cloud experiences wherever you wish, any public cloud, any data center that you control, anything else. And so what are those benefits? What are those kind of common deliverables that you can expect to give your business as an operator? On-demand service, the ability to have a developer be able to push his application to the infrastructure he needs without having to ask a lot of questions. There is no need for the developer to interact because you've already set up a cluster to do what you need it to do. Broad network access. That doesn't mean that the entire external world has access to everything in there. What it means is if I need an application that has a front-end HTML or whatever site, and I need to bind to a back-end database, or I need to bind to a Redis, that I have the ability to do that without having to call the firewall team, without having to call security, because it's already generated inside your cluster that will allow those traffic ports to go through within your cluster. So it gives you broad ability to generate kind of whatever you need in a self-service way, broadly across any type of application that you would be able to do. And it's resource pooling. You know, if you're going to buy 5 systems for application A and 6 systems for application B, but they really only probably need 6 systems overall, well, just buy 6 systems, put them all together, and then run your namespaces that allow them to kind of use that same resource and pool it together and make that kind of function how you want it to function. It's got rapid elasticity. We didn't really go into kind of the scalability of Kubernetes, but based on whatever criteria you set, it will go up to meet whatever demand you have. You may have a company that you may have a bank, and the bank may say, hey, I have people come in on the 15th and 31st to look at their bank accounts. I want to scale it by time. I want to scale it by utilization. But the key to scalability isn't that it goes up. Going up is actually easy. Going up is kind of like a government budget. But does it ever come down, right? And elasticity means it will actually come down. So you save money. There's no reason to run 300 containers to service your busiest Black Friday shopping day at midnight on, June 3rd, right? I mean, AWS exists because that's what they were doing. They were running this huge infrastructure to handle their Black Friday, and they said, well, this is crazy. Let's sell it out, right? So this allows you to do the kind of same thing internally. You will automatically scale down based on the limits you set. it's a measured service. You know who's using it. You know how they're using it. You know how much you've given them to use. When they need to use more, they simply change that file and it will use more, and Kubernetes will smartly put that new container on whatever hosts are appropriate to handle that kind of level. That's what cloud computing is. That's all that it is. It's not a place. It is giving your business these things, which is what's driving them to go to the public cloud. I want these things. I want to put my credit card down and be able to do what I want to do when I want to do it. Well, if you can deliver that internally or inside your cloud provider by giving this with the security of knowing you as an operator have made this really tightly controlled while giving them the control to do their job quickly and easily, that's what you're trying to achieve with cloud computing and with Kubernetes specifically, and containers with orchestration generally. And these are some just kind of basic resources we have. We can send this out, Kubernetes.io. There's a cheat sheet. There's some basic commands. If anybody is an operator here or is just a techie, geeky guy and they want to spend 20 or so hours of their life learning every nuance of this, you're going to go to GitHub. You're going to go to Kelsey Hightower's GitHub, and you're going to do Kubernetes the hard way. You're literally going to stand up nodes. You're going to generate certificates. You're going to pass down by hand. You're going to know how Kubernetes works. And so any security question you have, you'll be able to answer real quick because you've seen it, because you've built it by hand, no automation. It's a really good tool, and it's very, very well laid out for you to be able to do and kind of understand the inner workings really, really in depth. And that is definitely the end of the slides.
All right. So I'm just going to thank you guys. I think that's really helpful. Every time I watch you guys do this, I learn something else. I also am going to give a shout out to Kubernetes the Hard Way, Kelsey Hightower's post there on GitHub. I dug into that for about 10 of the probably 20 hours and definitely accelerated how well I understood Kubernetes, and you can really start to see the impact to how operations happen. So,
Michael, you didn't do all 20? You're a quitter, Michael. You got to do all 20. You got to do more.
I guess I have the time to do that, right? So it's good. Any other closing comments, Phil or Art?
I want to thank everyone for your time today.
Yeah, and same here. Thank everybody for coming on. This is our first one of these. I'm going to try to have another one of these, just talking about hybrid cloud and how it kind of relates to those principles I talked about. And yeah, please do feel free to reach out if you have any questions about getting started inside your environment.
Yeah, absolutely. I really appreciate you guys joining us today. We have another couple of these scheduled as well. Art mentioned the one that's coming up around hybrid cloud architecture. I'm going to have a conversation next week with Anuj Tuli, who's the CTO for Kiva, who's our automation orchestration sister company, digging into some of his experience on some specific use cases. So I'm excited about that. Anuj has been doing this for a long time. He's got some really good stories, some good, interesting use cases. A couple weeks after that, I'll be talking to Nate Austin, who's the practice director for our enterprise monitoring and analytics practice. So hopefully you can join us for a couple of weeks as well. If you guys have suggestions or if you found this was useful, really interested in your feedback, we put these together for your benefit. So looking forward to hearing from our clients, and appreciate you guys being on the phone today. Hope you have a good weekend, and so long.
Thank you all.
Thanks, everyone.
Thank you.